Let's review arc length and sector area. First, let's find the area of the shaded sector. Now, when you're asked to find the area of shaded sector, make sure you find the area of the shaded sector and not some other sector in the circle. All right, so we're given the essential angle of 115 degrees, but that's not the sector we're interested in. That's not the shaded part. We need this central angle instead. And whether we're finding a central angle or we're finding the intercepted arc, they're exactly the same, right? So the central angle is 115 degrees. This arc is also 115 degrees. Together, if we add arc AC and arc ABC, we have the entire circle, which is 360 degrees. We know arc AC, that's 115 degrees. If we subtract 115 from both sides, we'll find that arc ABC and the central angle is equal to 245 degrees. So this angle here is 245 degrees. Now that we know the measurement of the central angle, we can find the area of that shaded sector. Right? So as a reminder, sector area is central angle or the intercepted arc, they're exactly the same, over 360. This gives you the fraction of the circle times pi r squared over 1. All right, so let's identify all of our important parts, right? We have the central angle, that's 245 degrees. We need the radius. We're given the radius is 10 feet. So that means that the sector area of that shaded sector is going to be 245 over 360 times pi times 10 squared. Let's square first. So that gives us 245 over 360 times 100 pi. Right? And now it's a good idea to reduce. This is easier to reduce first with smaller numbers than to wait and reduce later on. Right? And you can either reduce numerator to denominator. It doesn't matter if I reduce the 245 with the 360 or the 100 with the 360. Chances are I'm going to be able to reduce both a little bit. Well, right away, 245 and 360, they are divisible by 5. And I'm going to move this down a little bit just so I have enough space. So 245 divided by 5, well, 24 divided by 5, that would be 4. I'd have 4 leftovers. 45 divided by 5 would be 9. And 360 divided by 5, 36 divided by 5, that'd be 7. I'd have 1 left over. 10 divided by 5 is 2. Well, I'm done with the 49 and the 72 because although 49 is not prime, it doesn't have anything in common with 72. 49 is 7 times 7. But I can reduce this with the 100. I know both of these are divisible by 4. So 100 divided by 4, that's just like there's 4 quarters in a dollar. 72 divided by 4, see 7 divided by 4 would be 1. I'd have 3 leftovers, and so that would be 18. All right, so we can't do any more reducing here because none of our terms have anything in common. I got a 7 times 7, a 5 times 5, and neither of those are factors of 18. So let's just multiply. And I'm going to grab a calculator out, and I'll just pull the one off to the side here. All right, so we have 49 times 25. All right, that's going to be 1,225 pi divided by 18. You'd think that would reduce, but it doesn't. And that is feet squared. And there we go. There's our answer. All right? Sometimes it reduces really nicely. I mean, you just have an integer value. This was not one of those times. We got kind of a big number. But that's okay. That's all there is to it. And if you don't see your answer there, double check and see if you can reduce more. Right? Here we knew we couldn't because 49 is 7 times 7, 25 is 5 times 5, and 18 is 3 times 3 times 2. It's nothing in common there. All right, let's go on to the next one. All right, here we want to find the length of AB in terms of pi. All right, so we're just finding this length. We've got everything we need. We've got the central angle. We have the radius. All right, so our angle is 80 degrees. The radius is 6 inches. And as a reminder, arc length is the central angle over 360. That gives you the fraction of a circle. And then circumference times the formula for circumference, which is 2 pi r. Right, pi r squared is for area. 2 pi r is for circumference. All right, so let's set this one up. So we have 80 divided by 360 times 2 pi times 6. And that's the length of arc AB. All right, so right away I say I can cancel out the zeros. Probably should just do that. 8 and 36 are divisible by 4. 8 divided by 4 is 2. 36 divided by 4 is 9. 6 and 9, both divisible by 3. 6 divided by 3 is 2. And 9 divided by 3 is going to be 3. And that's it. We've done all we can. All right, so we'll just multiply in the numerator. We've got a 2, a 2 pi, and a 2. So that would be 2 times 2 times 2. That's 8 pi thirds inches. And that's it. That's all there is to this one. 2 down, 3 to go. Let's find this one. Let's find the length of arc ABC. Now that's a little bit tricky, all right? Because we don't want, this is not our central angle. That's for arc AC, all right? So the 72 degrees, that goes with arc AC. We want arc ABC. And if you notice, together, arc ABC plus arc AC add up to be the whole circle, or 360 degrees. We know arc AC is 72. Let's find arc ABC. All right, so subtract 72 from both sides. Arc ABC is going to be 218. Right? No. Somehow I lost something there. 288. Yes. So I was just like, I took away the 60 and then how much more, but for some reason I took it off of the wrong number. So 288. And if we check, all right, so if I add 70, that would be 358, and 2 more would be 360. So that's correct. So 288 degrees is our central angle right here. Same as the arc. So the length of arc ABC, remember, it's the central angle. In this case, that's 288 over 360 times 2 times pi times r. And our radius is 12 feet. Let's see what we can do to reduce here. I'm just going to write that again. Well, 36 and 12, 360 and 12 are both divisible by 12. 12 divided by 12 is 1. 360 divided by 12, well, 36 divided by 12 is 3, so that would be 30. I could reduce the 2 and the 30, that would be 15. 288 and 15 are divisible by 3. So this would be 5. 288 divided by 3, so 28 divided by 3 is 7. I have 1 left over. 18 divided by 3 is 6. And that's going to be it. So arc ABC is 76 pi fifths, and that's feet, just feet, because this is length. Right? And there's another one. Let's do 2 more. All right, so here's another area. Let's find the area of the shaded sector. All right, so don't forget, you got to find the area of the shaded sector. 40 degrees is not the shaded sector. But 40 plus, oh, I didn't put any letters here. All right, let's just make it J, K, L. So 40 degrees plus arc J, K, L together equal the whole circle. If we subtract 40 from both sides, that leaves 320 degrees for arc JKL. Find the area of the shaded sector. Remember, we take, so sector area is going to be the central angle over 360, which gives you the fraction of the circle, times pi r squared, which is the formula for area. All right, so we're finding, I'm just going to write sector area because I didn't label the center of the circle anyway to give a name for this sector. So the central angle is 320 degrees. The whole circle is 360. That's the fraction of the circle we want. And then we have pi times 5 squared. Let's square first. So that's going to be equal to 320 divided by 360 times 25 pi. Cancel out those zeros. 32, I'm going to reduce, this is not going to reduce very much. 32 and 36 are both divisible by 4. 32 divided by 4 is 8. 36 divided by 4 is 9. And that's going to be it. And I don't need a calculator for this because that's like 8/4. So 200 pi over 9 inches squared is our sector area. And that's all there is to that one. All right, so I hope this is helping you out.